I just want to kick this off because some people who have been around the community for a while may be wondering, why the heck are we doing this Phenotype February thing again? Haven't we already spent way too much time on phenotyping? Isn't this problem already solved? Indeed, Azza and Anna and Weaves and Gautam and Asi are going to talk to you about what we're doing this month, but I wanted to provide a very brief vignette of why, to motivate why I think this is an important area for our community to really be focused on, and an area where I think Odyssey as a community has a great opportunity to contribute, and I'd frankly argue an obligation to really try to move the entire scientific community forward. And this is quite timely. So next slide. So why we still care about this? So literally last night, I just was poking around looking at articles, just reading them for enjoyment. And I found this paper that was published in JAMA Psychiatry this week. So this was, I think it came out like 6 days ago. It's titled Prescription Stimulant Use During Pregnancy and the Risk of Neurodevelopmental Disorders in Children. And this paper is a very nice piece of work of observational study that's trying to examine a very important question. And if you click ahead once there, please. In this paper, they describe that they are using Medicaid claims data as well as market scan commercial claims and encounters database through 2020. And then they described in their paper, as we would normally do in most of our papers, there's some sort of an outcome description. In this particular context, they describe their outcomes in the following paragraph. They say neurodevelopmental outcomes, that any NDD was defined as a composite of ADHD, specific disorders, et cetera, But then they say, validated claims-based algorithms with high positive predictive value were used to define each outcome, see supplement 1. If you were to click on that supplement 1, you get this table that just popped up. And I'm going to focus here specifically on ADHD, the second row in the table. What they've listed here is the operational outcome definition listed in their supplement for their paper. And it describes that they identify cases of ADHD as patients who are aged greater than 2, who have either 2 dates of an ICD-9 code of 314. Star, or 2 dispensings of an assortment of drugs for ADHD, or 1 ICD-9 code of 314 and 1 dispensing of a drug. So in the chat, for those who are paying attention, does anybody see any issue with this yet? Or anybody can unmute if they see an issue yet. All right, well, I'll let you think about that for a second, but I just want to highlight again, this is a paper published this week, published in JAMA Psychiatry by a very good research group, and they do really excellent work in evaluating pregnancy safety. It's a super important question, high impact journal. This is the algorithm that we've got just this last week. If you go to the next slide. In addition to citing the saying that this was a validated algorithm, they provide a reference, and this is the same authors published a nice paper in Pharmacoepidemiology Drug Safety back in 2021, and it was entitled Validity of Claims-Based Algorithms to Identify Neurodevelopmental Disorders in Children. So same group actually did the stewardship to think about how to develop a phenotype and evaluate it, and then publish that so that they could cite that paper in their subsequent work, which is the one that just came out just this week. Now, in that paper, you can see here the table 1 in the validation paper does indeed confirm that same algorithm that was shown in supplemental 1. So that's good that they're citing something that's referred to. And then if we click ahead once more, you can also see what they did for validation. And in this specific case, they took a random sample of 50 cases of ADHD amongst their 9,700 cases that they had, and they clinically adjudicated them, much akin to the work that Martijn and Anna showed at the symposium last year, thinking about how to do case review. And they did that to ultimately estimate a positive predictive value of 0.88, with some descriptions of the cases that didn't satisfy the definition, why that was. They also, though, in this box in red that's already popped up here, highlighted in the paper some of the limitations of their validation study. Most importantly, they said, finally, we did not validate ICD-10 codes to define neurodevelopmental disorders. However, when converting our codes, we found good correspondence between the ICD-9 and the ICD-10 codes. For instance, ICD-9-299 corresponds directly to ICD-10. We therefore expect a very similar performance of NDD algorithms using the ICD-10 codes that we've identified. So in this specific case, we've got a paper that came out this week using data through 2020 based on a validated algorithm of ICD-9 codes with a crosswalk from CMS saying that these ICD-9 codes might correspond to these ICD-10 codes, using a 50-case validation as a mechanism of determining that definition is appropriate. Now, we hopefully that this is okay and that mapping is okay, but even here being left with the fact that we still need to do validation of ICD-10, particularly given that the data sets themselves that they're working on are the majority of the data is well past October 2015 when ICD-9 codes no longer existed in these claims data sources that they had. If we peel the onion just a little bit, so I got really interested and curious about this last night. So we peel the onion, go to the next slide. I was wondering, well, okay, this study's been done. I wonder if anybody else has bothered to think about ADHD as a neurodevelopmental disorder in children anytime recently and how they went about that. And this was a paper that was published in another high impact journal, JAMA Internal Medicine, published only 3 years ago in 2021 by colleagues and collaborators in our own community who were specifically looking at the association between antipsychotic use in ADHD, maternal antipsychotic use, and then ADHD in children. And so in this paper, if you click the next slide, oh, I'm sorry, stay right there. I'm sorry, go back. Yeah, so the outcomes is listed on the right-hand side here. So in this particular case, same exact outcome for the same kind of circumstance, which is we're looking for ADHD post-pregnancy exposure. Here, they've defined the outcome as ADHD is either an ICD-9 code of 314 or, so a single diagnosis code, or a prescription of ADHD, specifically methylphenidate or atomoxetine. So here you have a different algorithm for identifying cases of ADHD. It happens to use the same ICD-9 code parent. However, the logic associated with how do we find cases is quite different. If you go to the next slide. So this got me curious because, of course, in our own community, we've done research on ADHD. And in fact, in our first Phenotype February back in 2022, I wrote this big long rant about ADHD and how we need to be really careful about phenotyping this, particularly given that the ICD-9 codes that one might use might not actually be fully subsuming the entire international network that we're doing. We go to the next slide, though, highlight that our community's made progress. We have created a standardized definition of ADHD. It is published in our Odyssey phenotype library. It has a full implementation in our Atlas tool, but our definition is even different from that first paper from Suarez et al. In JAMA Psychiatry, and it's different from the paper that's in JAMA Internal Medicine, because our definition looks at a diagnosis code or a procedure or somebody who started on a drug but then had the diagnosis within the year following. And so we've got this case that we've got high impact journal papers coming out in the last couple of years. They're using different algorithms, differently specified, differently organized. And then one could ask, so who cares? Maybe the stuff doesn't matter. And so just briefly, got curious enough about it that I just decided to say, let's implement these 3 different algorithms and let's just see, do they in fact find the same patients across different databases? And what we can actually see in this table, so that first row is the paper that came out just this week. That requires 2 diagnoses or 2 dispensings or a diagnosis and dispensing. That second row there is the paper by Wang et al. That looked at, from JAMA Internal Medicine, looking at 1 diagnosis or 1 treatment. And then you've got our Odyssey phenotype library that's looking at 1 diagnosis or 1 procedure or 1 treatment with a diagnosis and the 365 after. And what you can see across all of these columns representing different databases that you do indeed get different patient counts. And the question would be like, how much does this really matter? Well, depending on which database you're looking at, this could matter 20%, this could matter 80%, or this could matter 230% variation between the high and the low of these different algorithms. And it's gotten me to be quite worried about the current state of our community, not just Odyssey, but the broader research ecosystem. If it's the case that in 2024, with high impact questions in high impact journals, with high stakes questions that matter to lots of patients, that if we can have a twofold difference just because we're picking different algorithms with questionable validation and inappropriate justification for us to reuse these definitions, then we really got a problem that's kind of fundamentally going to undermine the ability for us to do reliable real-world evidence generation across our data network. And so Phenotype February is going to be an opportunity for us to take stock of what the state of what we're doing, what is the science of phenotyping, and what can we as a community do to collaborate together to try to really improve this science and improve the foundational elements that we're working on. And so with hopefully that is a specific, tangible example. I'm going to turn over the team to talk about opportunities for all of you to be able to participate in Phenotype February and try to improve the science.
Okay, so we have 152 people on the call today, and assuming that few of you are actually new or joined this year and have no idea what do we mean by Phenotype February. So for the newcomers this year who did not participate in Phenotype or did not know about Phenotype February that we did last year and the year before, I'm going to have a ceremony starting 2024 Phenotype February by reading this quote where Patrick started Phenotype February in 2022. So he said, "It's finally arrived, the wonderful month when we can put all our troubles aside, or your troubles aside, cast off this New Year's resolution you're already failed at, and enjoy the freezing cold New Eastern US weather or the Australian heat, and just focus on phenotyping." So that is what phenotyping is. It's Phenotyping February. It is a month for us as a community to just focus and drive focus on the field of phenotype and phenotype development and evaluation. So for this year, or before I go to this year, Anna, can you go to the next slide? So we started this exercise in 2022 when Patrick started the custom or the exercise. And in 2022, what we did is we signed up for different days in February where each of us worked alone to start a discussion on a condition or an idea where we phenotype it, each on our own. And we had 28 days with starting a discussion on 28 phenotypes. By the end of the month, we ended up with developing 15 phenotypes and shared with the community. We evaluated those phenotypes using Odyssey tools, and we started different discussions about the 28 phenotypes. We also presented all this work in the symposium of that year, which was nice. But in 2023, we thought, could we learn from what we did in 2022 and maybe come up with a sequential or the process or the flow of work when what one can do when we collaboratively develop and evaluate phenotype together. So instead of working alone, each person on 28 phenotypes, we decided to work on 11 phenotypes where we worked in teams and groups. Following a process or sequence of steps, and we worked on 11 phenotypes. We discussed them on the forum. We also debated on the forum about 4 different topics related to the science of phenotyping. And we ended up with those phenotypes developed, evaluated, and many of them are already are getting written in the manuscripts. The best part of Phenotype February in 2023 is that we have 32 new collaborators who interacted on the forums, learned how to use tools, thought differently about the problem of phenotyping, and we ended that month feeling the energy of how can we collaboratively follow a process to develop and evaluate phenotypes. For this year, though, starting where Patrick ended on we all understand that even when we worked the last 2 years, we talked about how we can follow principles, how we can follow a process. But a great gap that we understand, and Patrick presented an example of it, is what is the current practice of phenotype development and evaluation in existing observational studies. So we thought that this year we will focus our goal to understand what is the current practice in the field, and how much research introduced variability in the process of phenotype development and evaluation. So was that ADHD example just a cherry-picked example that Patrick hanged on, or is it actually the situation across the different ideas and clinical conditions? So what we have proposed to do is a month-long collaborative study that focused on the assessing the consistency in phenotype definition components, in the phenotype representation structure, that is how different papers present and report their phenotypes used in a study, and the phenotype validation method. So those are 3 different things that Patrick showed how in the ADHD example, we had different phenotype. The papers represented their phenotype differently, and then some talked about the validation method and another didn't talk about any validation. So the idea is to be more specific. Next slide, Anna. Our objective is to assess the heterogeneity in phenotype definitions, representation, and evaluation method across published observational studies for 4 clinical conditions. So every week of February, we're going to pick 1 condition, and we're going to do a literature review, where we're going to get all the published observational studies that were reported on a phenotype related to that of that condition, and we're going to at the end assess the variation in the phenotype algorithm themselves, in the representation of that, and in the evaluation method used in these papers. What are those 4 phenotypes? We don't know. Today, you get to vote, and we get all as a community to find 4 phenotypes that we're going to do a full literature review for, replicate their phenotype algorithm, and understand the heterogeneity in those 3 different dimensions. What we did to help the collaboration across the entire community, since we got a feedback that the process of phenotyping is complex, and our amazing collaborators last year in specific suggested that we make it more of manageable task that people could sign up on. So we're going to break the entire study method into specific manageable tasks, and people get to sign on 1 or 2 tasks depending on their availability and their interest and their background. We're going to progress our tracking through our Tuesday calls, just like we did last year. So every Tuesday, we're going to give a progress to the community of what we achieved for the week. We're going to, just like the last 2 years, we're going to utilize the Odyssey forum in addition to Teams to do all our communication and updates. At the end of this study, we will have a manuscript where we're going to summarize our findings on the discrepancy or heterogeneity across phenotype definitions, representations, and methods of validation for 4 clinical conditions. We also, out of this exercise, want to come up with a standardized template where we recommend a standardized way of representing phenotype definition for the entire community, so people can use that when they write their manuscript for their own studies. So it's not like every time I have to think, how am I going to represent this phenotype algorithm? What supplementary material do I need to add? How do I get this information out of Atlas? We're going to try to come up with a template where we provide it to the community, so we as a community consistently represent our phenotype definition in a manuscript or any published work, including all the supplementary material that allows somebody to replicate those definitions. And that would be it. Now, before we go, now I'm not going to give us more details of how those tasks are broken and how we're going to collaborate. But before we do that, we're going to take 15 minutes where Jamie is going to set up the page on some terminology and concept that we use inside the community when we talk about phenotype. Think of this as 101 phenotype evaluation and development. So hoping that if everybody understands, then we have more people excited to contribute to the study that we want to run this month. Jamie?
Thanks, Azza. And I guess it's up to the rest of you to determine whether I'm in fact qualified to be teaching phenotyping 101. So you tell me. So I'll just go through some background in about hopefully 10 to 15 minutes. And start just by referencing this nice document from the FDA that describes what we call in OHDSI a clinical description. And I'll just read this one sentence that says, FDA recommends defining an outcome of interest, or that we can think of as a clinical concept of interest, based on the clinical, biological, psychological, and functional concepts of the condition or clinical concept as appropriate. The conceptual definition of the condition or clinical concept of interest should reflect the medical and scientific understanding of the condition. So you can think of this conceptual definition as something that should be able to be operationalized in real-world data sources. And that operationalization is what we call a phenotype algorithm. So the principles of phenotyping, they start with this clinical description, and those elements, as many of you might be familiar, is an overview, a presentation, an assessment, a plan, a prognosis, and disqualifiers and strengtheners. And with detailed information on all of these clinical description elements, we should be able to use them as a guide to phenotype, to developing our phenotypes. So if you go to the next slide, here's just an example of the clinical description for acute pancreatitis that we developed in conjunction with some clinical experts on the basis of this information from the National Library of Medicine NIH website. So this has some detailed information that we can go and try to operationalize when we design our phenotype algorithm to apply to a database. So this paper from 2015 really hits on a couple of key high-level points of identifying phenotypes in healthcare databases. And its main points are really that accurate case ascertainment requires pretty detailed knowledge of the clinical diagnosis and treatment patterns relevant to that phenotype, a strong understanding of the care-seeking behavioral characteristics of the phenotype, and good background database knowledge on its intent, like the original purpose of the database's construction, and then the completeness and reliability of the content. And just seeing these, if you just go back for a second, when you see these required knowledge, I don't know about you, but my almost 10 years in this OHDSI community now, I see a lot of that knowledge on a regular basis collaborating with you all. So this is a very good thing in my opinion. We move on to the next. The principles of phenotyping were furthered in this really seminal paper by George and company that defines a phenotype as an observable, potentially changing state of an organism. And this potentially changing state is critical because it really implies that health isn't static. It is a changing state of being over time. And the goal of phenotyping is to draw conclusions about a target clinical concept from clinically relevant data. And that phenotype algorithms are intended to identify phenotypes which are generated by domain experts and knowledge engineers. And the purpose is to maximize fidelity of the phenotype algorithms to the clinical description through richness and acknowledging bias from healthcare processes. And this healthcare processes piece is, was brought up in this paper that we just looked at before, that really having a strong understanding of this is going to help us identify phenotypes that reflect the target clinical concept. Next, please. So moving forward, this is a very recently published paper in JAMIA that comments on the current state of reporting standards for phenotype algorithms in biomedical research. And it's made, the premise of this paper is that phenotypes are crucial to research, but a lack of standardization and a lack in transparency really inhibits evidence generation validity and, more generally put, the promise of real-world data and real-world evidence. And the main points here are these 5 recommendations that they say are fundamental dimensions of phenotype algorithms. I note I should have spelled fundamental with a PH just to be on track with the rest of us. But these 5 dimensions are complexity, performance, efficiency, implementability, and maintenance. And I think there's it's worth speaking just a little about these dimensions. Complexity is a way to think about that is with detail, with detail comes better understanding. In shallow algorithms with simple combinations of coded data with a few operators might not really do justice to the detailed clinical description that we're working with. And so to paraphrase Occam's razor, we want to make these phenotype algorithms as simple as possible, but not simpler. And so there's this complexity piece that is, again, in line with George's earlier paper, which speaks about richness in what's available to use. Performance should always be in mind. And the idea here is that any phenotype algorithm can be measured in terms against some reference standard to get our regular measurement error metrics like sensitivity, specificity, PPV, and NPV, and to also consider quantifying fairness and equity in order to avoid disproportionately affecting marginalized or underrepresented groups. And this is a piece that was kind of new to me, in that I know that this is a goal to try to achieve in observational science, but really thinking about that at the stage of phenotype defining phenotypes seems like a pretty good dimension to consider. There's an efficiency piece where we know that there are thousands and thousands of phenotypes needed, but developing them one at a time is definitely constrained by time and resources. So it suggests that high throughput phenotyping is really needed. And it makes me really glad to know that we have a really, really big standardized network full of dedicated and really brilliant people to support such an initiative. And then implementability, again, is depends on phenotype complexity and requirements. And these problems are less applicable to us in the OHDSI community, given that we have a data standard that is and lots of data, but it's definitely something that needs to be considered when creating these phenotypes, because they might not, even given our standardization, might not be able to be implemented everywhere. And then lastly, there's this maintenance piece. And the maintenance piece suggests that these phenotypes really have to be adaptable and regularly updated, and that maintenance is crucial for the continued accuracy, relevance, and usability of any phenotype. So really what Wei and company reminds us is that for any phenotype developing, we need computational skills, data extraction competence, clinical knowledge, and strong understanding on data model representation and biomedical terminology. And so this, to me, sounds like it's a team sport, or something that a motivated community with shared objectives can really do effectively and efficiently. So this paper concludes with a quote that creating and proliferating an integrated data ecosystem with harmonized phenotypic data across data providers through a community-focused, open, and standard-based approach is essential to enable discovery science at scale. So I don't know about you, but I think that last sentence can be paraphrased quite nicely into, we need a good phenotype library with well-designed phenotypes across the entire community. So in this last few minutes, if you go to the next, and then I failed to ask, this principles of that Wei and company have reported, it just makes me ask the question, does this recommended state of affairs sound like what we just heard about in the current ADHD phenotype situation? Probably not. And then second, does this recommended state of affairs sound like something that is achievable by OHDSI with strong collaboration and single focused motivation? I think it does. All right, so lastly, this last one is just going to be a reminder. If you go to the next slide, please, Anna. I'll just do a brief reminder of cohort definitions. Cohort definition is a phenotype algorithm, is a specification of how to identify a cohort. And if you apply a phenotype algorithm to a data, it returns a cohort. And the definition of a cohort is 0 or more people who satisfy 1 or more inclusion criteria for a duration of time. And there are several objective consequences to this. Namely, one person may belong to multiple cohorts. One person may belong to the same, may belong to the same cohort at multiple different time periods. And there are several more. I won't go into them, but mainly the main ones are a code set's not a cohort, and logic for how to use the code set in a criterion is required. Last one, please. So the components of a cohort definition, all of this complexity that we were speaking about earlier, how to really maximize the fidelity between a clinical description and its operationalization can be done using this cohort structure. And namely that every cohort needs to have an entry event, which we can think of as the index state, which is usually a time-stamped observation for persons such as a drug exposure, conditions, procedures, etc. And these events have to have a start date and an end date, although some events like a measurement might have the same start and end date. And then these entry events have to satisfy some entry event inclusion criteria. And this is what will give you your initial cohort. And then you can further add additional qualifying inclusion criteria, which creates the qualifying cohort defined as all persons with an entry event satisfying initial event inclusion criteria and then subsequently fulfill all the additional qualifying inclusion criteria. And then lastly, and importantly, which is not seen consistently across the field, is that cohorts need exit criteria. And there are various ways that you can specify that, including an end of just the end of observation period or the cohort of a fixed duration, or a cohort era end, or some censoring event. So hopefully that is a quick refresher. And to go into these different buckets of a fully specified cohort, there's this idea of domains, concept sets, and domain-specific attributes and required temporal logic. And it's this temporal logic that's the interval during which the relationship to inclusion criteria and entry events are evaluated. And these, the entry event and the inclusion criteria are all defined by using domains and concept sets with their specific attributes relative to the index, relative to the entry event. And what I found interesting about the ADHD definitions that Patrick went through at the beginning is very few, I don't think any of them actually included temporal logic. There were a few conditions that said more than one occurrence of something, but it didn't actually define when relative to each other that should be, nor which of those events was actually the entry event. Was it the first or the second, or it wasn't really clear. So this temporal logic seems to be missing a lot of the time, and it's critical. So let's just remember these kind of basics as we move through the tasks that Azza proposed earlier. That's going to be the main bulk of the work we're going to spend this next month working on together. Next, please.
Patrick, can you start the poll? So we're going to now decide on the 4 phenotypes that we're going to.
So the poll should be open, so everybody should be able to go to pollev.com/PatrickRyan800. I see already some people are voting, but if you can go to that, and I guess I'll paste it in the chat as well for those that need the link. But if you go to pollev.com, because of the technical challenges, I can't actually show my screen here, but I'm seeing that people are voting. And maybe I'll take a screenshot and then be able to pass it over on and we can get to it back at the end. But looks like people are still voting here. So if you just go to pollev.com, pollev.com. Oh, there you go. Craig just posted it. Thank you, Craig. I see lots of voting. So here we're specifically identifying diseases that we may be interested in going after. There's already a bunch of good disease options that are put in here now. I see there's interest in prostate cancer, in Alzheimer's disease, bladder cancer, pulmonary hypertension, rheumatoid arthritis. Getting lots of votes today, which is great. Small cell lung cancer. You can also, of course, add your own diseases of interest. I see somebody's added colorectal cancer, type 2 diabetes. Can't get enough type 2 diabetes algorithms. Depression. Major non-cardiac surgery. See, osteonecrosis of the jaw. So I think that must mean Robert and his dentistry team is on here representing. Well done. We got long haul COVID, type 1 diabetes. So we got lots of different disease options. We'll keep this open throughout the rest of the meeting. It looks like there's quite a lot of votes for Alzheimer's disease right now. We'll leave this open. Actually, I'm glad to see so many people voting. And we've got a bunch of options. I think, Azza, as you guys are going to go through this, we'll talk about how we're going to try to identify a small set of these diseases that, as a community, we can go after and tackle.
Yes, we do have a hand raised. Somebody have a question before we move forward?
Yeah, and this, I'm not sure how important this is, but it's something I didn't really fully appreciate until just fairly recently on a call with Christian. And it had to do with the fact that our model for the data model, and Jamie mentioned that knowledge of how the data is set up is actually pretty important, assumes it's a closed world and that there isn't, if it's not in the database, it's not there, as opposed to just not recorded. And so it seems to be a very fundamental difference about the way we handle data versus maybe the rest of the world does. And so does that impact our phenotypes? Should that be somewhere included in assumptions? Anyway, it was such a big thing that I didn't really realize for the first several years of working with Odyssey. And I didn't, so anyway, I'm raising it, and maybe is it part of the introduction to phenotypes, or if it's not relevant, then it doesn't need to be part of the introduction to phenotypes.
Well, I'll just chime in real quickly. I think it's a good point to raise. Fundamentally, when we talk about phenotype development, we're talking about how do you construct an algorithm that's going to find you people who you believe have, belong to the phenotype. When we talk about phenotype evaluation, this is where we're actually trying to quantify the measurement error of a given algorithm. And so I would actually assert you kind of have to have some sort of closed world assumption to do any sort of phenotype evaluation, because fundamentally you're saying in order to measure sensitivity, specificity, and positive value, you need to have some basis by which you believe that there is truth, and truth is going to be the presence or absence of that disease, and you're evaluating your phenotype algorithm against that. Now, the consequence of why do you have measurement error, that's actually where the closed world assumption could simply be your data doesn't really well satisfy the closed world assumption. That is, maybe you have data leakage, or you have issues that we are able to quantify with measurement error using the closed world assumption. But I don't think it actually changes the fundamental basis of how you think about constructing a phenotype, given that you only have available whatever elements are captured in your data.
So the addition of exclusion criteria, where it just seems like when you think about a quality measurement algorithm, for example, they'll often express certain exclusions explicitly, where you might not know that in an open world database, but in a closed world database, if it's not there, you can assume it's not there as an exclusion criteria. So anyway, I really appreciated that. It's really the validation, and it just might be different how our phenotypes perform outside of OMA versus inside. Inside, we should all have the same assumptions, so they should be good.
Absolutely.
Thank you for that.
Alrighty.
Yeah.
That sounds like a wonderful conversation, and a very appropriate conversation for one of Phenotype work group calls. So I encourage everybody to come to these calls even beyond the Phenotype February. Now we voted for the phenotypes we want to review and evaluate together. So now let's look at the specific tasks we want to do together. And here we broke them down again into very small, specific, tangible pieces that we all feel we can accomplish together relatively fast. And as we go through them, we will see that some of the tasks require some technical expertise, while others do not require so. So if you want to participate, you will be able to find a task that fits your interests and skills. And at the end of this call, we will have a form where you will be able to sign up to these activities. So as we go through these, you will see the very same activities in the form, and you will be able to select as many or as few as you want. So we will have 4 conditions for 4 conditions, and for each condition, we first need to assess what's done in the literature, what people have already built, what they report. So the very first task for us to do together is to perform literature search, and luckily we already have queries to do so. And once we perform the literature search, we will identify the papers that have phenotypes, that have some descriptions of the phenotypes, and we will select them for further investigation. Then the second big step that is split down into smaller pieces is to actually describe what people have done. So the very first thing is simply to describe what phenotypes were used, what concept sets were used, what logic was used in those phenotypes. Then the next step would be to summarize how those phenotypes were similar and different, something very similar to Patrick has done on this call. So basically what the differences and similarities across already published phenotypes are. We also want to summarize and characterize what approaches people take to validation. Do they cite other papers? Do they validate their phenotypes themselves? If so, do they use chart review? Do they use other tools? This would be a task to simply summarize what people have done for a given condition, what researchers have done for a given condition. And because we've seen that different papers and different researchers report studies differently, we also want to do something that we believe has never been done before, and to characterize simply how those phenotypes were reported. Were there figures used? Did they use appendices? Did they use code sets? What kind of code sets? So everything related to reporting. Once we have these nice summaries, the next step will be to take those phenotypes that we identified in the papers and try to replicate them in Atlas. So apparently this task will require some knowledge of Atlas, but luckily we will have sessions dedicated to building cohorts in Atlas. So if you want to learn more about how to build cohort in Atlas, that also would be a nice opportunity for you to get involved and also to contribute in a meaningful way to this initiative. Then once we create the cohorts in Atlas, we also want to look at the patients that we got included. So for that, we will run cohort diagnostics, and cohort diagnostics is a tool in the Odyssey suite. And if you want to participate in this task, you will need to run cohort diagnostics on your local data. But if you cannot do so, no worries, we will do it anyway, so you can participate in the next step, which is examine the output of the cohort diagnostics. And you can look at the patient characteristics, or you can look at the incidence rates of those conditions. And since cohort diagnostics is such a useful tool for examining your phenotypes, that would be a wonderful opportunity for you to get more familiar with cohort diagnostics in case you do not know much about that. And finally, we also will be writing everything up. Of course, we will need to summarize what we've learned, and at the very end, we will also, beyond this write-up, we will achieve several things. So first, we will just simply get the replications of published phenotypes for 4 conditions, which is nice enough already, because if you're interested in some of those conditions, you will be able to have readily available cohorts. Also, we will achieve, you will get some practical sessions on how to use Odyssey tools. So as I already mentioned, if you want to learn how to construct cohorts in Atlas, how to use cohort diagnostics, or if you feel even more adventurous and you want to learn how to use Phevaluator, that also would be your opportunity to both learn and also to contribute. We will summarize the practices. That is the goal of this months in general. So we will have a write-up of what's done in the community in terms of phenotype development, reporting, and validation. We also want to produce a template which everybody can use when to describe the phenotypes in their papers, because we know that sometimes it's quite a cumbersome task where people spend quite some time on it and never arrive at the same version of phenotype reporting. So having a template would help everybody who's writing clinical papers and want to describe their phenotypes. And finally, of course, we will get a paper out of it, which is always nice. That paper is something we will need to work more on, but that will not be done fully in the scope of the Phenotype February, but something that we will achieve later. No.
Maybe Asya?
Yeah.
Oh, okay. Sorry.
Yeah, sure.
Anna, do you want to finish, or I can try to? Okay, I'm going to be fast. And
yeah, please do.
Just to wrap it up, you have heard a lot from Patrick, Anna, Jamie, and Azza. Set up the stage was actually Patrick's example was great. And we talked a lot about heterogeneity. And one of the biggest problem is lack of transparency. My problem, and I think a lot of us who are doing a lot of research, is that we have really unclear idea of why people are making these choices and what's the nature, where it's coming from. And as a researcher who wants to use that, we still are trying and struggling to find a way to have a solution for that, to have transparency in why certain components and structures, where certain decisions are made, and what we need to do. Within the past 2 years, and also with Phenotype Library and everything that we do, we're trying to get there. Are we there yet? We've made a lot of achievement and accomplishment, but there's still a lot to be done, specifically trying to figure out and understand these limitations and finding ways towards a unified and structured solution that can help us. So each of us, for any of these studies, for any of these phenotypes, can go and be able to identify the right one that can answer our questions. Will be fun. Please come and join us. Anna.
All right. So, and that's a very last slide, is that we have Google form with 3 questions: your name and email, conditions you're interested in, and you can sign up to as many or as few, and also the task you want to do. And these tasks mirror the tasks that we just went through. They're very small, tangible, manageable things. And if you click or if you select the QR code, you will be transferred to this Google form where you can pick your conditions and pick your tasks. And once you sign up, we will get all the information together and we will set up the week 1 orientation in Teams. So please sign up so that we get your email, and then we will distribute all of the subsequent information through the emails and of course through our Phenotype workgroup Teams.
And the forum.
And the forum, of course. The more the merrier.
And
so,
we have his hand up.
Yeah, so I will just have this QR code here hanging so that you can sign up.
Hugely exciting. Everybody should join. It's really, it's so gratifying to see you building from year to year on all of this fundamental work. And I just had a suggestion that we include a comparison of how other people, including some of the literature that Jamie cited at the beginning, compare to our definitions. I think the equality of a phenotype definition and a cohort definition that includes things like look-back periods or being treatment naive on things and so on, whether that's really a health state, whether it should exist in an independent way apart from studies and so on. I think in order to do the comparisons we want to do at the end, we have to understand that we're defining things in a similar way across OHDSI and other communities that are doing things. And so some element of the paper that looks at the consistency and equivalence of definitions, what we mean by phenotype, would seem to really add value to this. It's my 2 cents, but go team, this is great stuff.
Absolutely, we are at time. Just a follow-up, because everybody will ask, what should we do? So if you want to join us, please do. Your only task right now is to go into the Google form that Anna shared on this QR, fill in information. That we finished voting and we have 4 winners. Those are going to show up in the form. And I think, Patrick, I can announce them now. Well, we ran out of time. Okay, we have Alzheimer, pulmonary hypertension, major depression disorder, and prostate cancer. Those were the 4 conditions that got most of the votes, so they will definitely be worked on. However, I understand that there were votes for many others, so maybe we'll talk about how we can do the rest of the work. But please join us, sign up through the form. There's going to be communication on the forum. We're going to have a Thursday call. We're going to make an announcement what time exactly to do our orientation of how we're going to collaborate, where you're going to find the material. And even if you just want to observe of how one can do literature review, how one can replicate things in Atlas, how can one evaluate things in cohort diagnostic, also join, because we're going to do this in public calls that you can observe if you can't contribute. But please join to contribute as well.